Hello students, good evening all. So welcome back to our next session of chapter differential equations. So far we have finished two sessions in this particular chapter. So in that we have started with the basic definition of differential equations and all, and then we have entered into the methods of solving the differential equations. Right, so first we'll just have a quick overview of what we have discussed in our previous session of differential equations, and then we'll jump into the topics that we are going to cover in our today's session of differential equations. So previous session we have talked about general solution of differential equation. So basically we have talked about solution, and then in that we have discussed the types of solutions, where we have started with discussing about general solution of differential equation as well as the particular solution of differential equation. So we have seen the typical difference between these two and how we will be finding the solution of the differential equation in a general way. Right. So after that we have even started with our methods of solving differential equation, in which we have first started with the variable separable method of solving differential equation. So in this we actually have three forms of equation. Right. So in this variable separable method we could expect three forms of equation, and amongst which two forms we have already discussed in our previous session, that is in our second session of differential equations. So in today's session we are going to start with the third equation form, how we will be solving using the variable separable method. Right, so we are going to start our today's session with this methods of solving, and in that first we are going to start with the variable separable method, in which the third form of equation we are going to discuss. And after this variable separable method, we are having the next methods of solving, that is solving homogeneous differential equation. Right, so in this we'll be seeing first what is actually a typical homogeneous equation. So what is the typical format of a homogeneous differential equation, and then we'll be proceeding and seeing how we'll be solving the homogeneous differential equation here. Right, so this will be our second form of differential equation, we can say, or else second way of solving the differential equation. And apart from that, we could even have differential equation in some other different forms, where could we actually reduce that into the form of homogeneous. Right, so if we could able to reduce the given equation in the form of homogeneous, then we could apply this method of solving the same thing which we have used for the homogeneous differential equation. Right, so method of solving homogeneous differential equation. So once we could reduce the given equation into the homogeneous form, then we could directly apply the method which is applicable to solve the homogeneous differential equation. And after that we are having one more method of solving, that is linear differential equation. So solving linear differential equations. Right, so as I mentioned in our previous sessions, I have already talked about linear equations, in where I have mentioned that in our future lectures we are going to learn linear equations, again linear differential equations. So here in detail we are going to look over how we will be solving any linear differential equation. So these are the typical ways of or methods of solving the differential equation. The first one is variable separable method, and then solving homogeneous differential equation, and then solving linear differential equation. So these will be our typical methods which we will be using and solving the given differential equation. So as I mentioned, today we are going to start with the we are going to continue with the variable separable method which we have started in our previous session of differential equations. So in our previous variable separable method, we have discussed two forms of equations. So this will be the third form here. So where the equation form will be dy by dx is equal to f of ax plus by plus c. So the function will be in this format. So initially In our previous forms, it is either f of x or it is g of y. So, or both f of x and g of y. So, those typical forms of equations we have already seen how to solve that. So, now the third form of equation will be dy by dx, which is equal to f of ax plus by plus c. Right. So, here what we can take is, so the inside function whatever is here, that we will be substituting as v in order to solve this type of differential equation. So, here ax plus by plus c will be considered as v, and from here we can differentiate this equation and we could get our format dv by dx, that format, right? And then we can further integrate it by taking the dy by dx, right? So, from where we can substitute dy by dx, so we can differentiate here. So, it will be a plus b dy by dx, which is equal to dv by dx, right? So, we could rewrite this dy by dx format and we can substitute here so that we can get in the form of our v, such a way that we could integrate our both sides of the equation. So, now the entire equation can be either converted in the variables of dy and dv so that we could integrate, right? Or else we can have at final the equation can be in the format of dy and dx so that we can integrate. So, the first and foremost step, so once we start with taking this to be v, the further steps we can automatically do it as how we are doing for our previous things. So, the first the step which we have to remember to in order to solve these types of differential equation is nothing but taking ax plus by plus c is equal to v, and then we have to proceed accordingly and simplify it, so in order to get the solution of this type of differential equation. So, let's understand this form of equation in a better way by doing a question here. So, first take a look over the question and try to understand it. So, take 2 to 3 minutes and give it a try first, and then we'll just discuss the question. So, in order to first what we can do, so let's write down the equation here. Given equation, differential equation x plus y whole square dy by dx is equal to a square. So, look over the question and see how we'll be solving it. So, in our previous just form, we have seen if we have equation in this form of ax plus by plus c, the thing is we will be assuming this to be either v or t. You can assume accordingly, and then we have to assume. So, according to this question, what is the equation, that is what is the function here, x plus y. So, we are going to assume x plus y is equal to t. So, the next step will be differentiating this. So, here 1 plus dy by dx is equal to dt by dx. So, in place of dy by dx, what can we substitute? So, dy by dx can be rewritten as dt by dx minus 1. So, now as we have got our substitutions, so now let's substitute in our given equation. X plus y whole square. So, in place of x plus y, we have assumed it to be t. So, let it be t square, and in place of dy by dx, just now we have got the expression in terms of t and x. So, let's substitute that. That means dt by dx minus 1 is equal to a square, right? So, now how can we rewrite this? So, from here dt by dx minus 1 will be equal to a square by t square. I am just rewriting the expression, and then from here dt by dx will be equal to a square by t square plus 1, right? So, let me erase this. So for after the substitution in place of x plus y equal to and simplification, we end up having the expression in terms of t and x in the variables t and x, that is nothing but dt by dx will be equal to a square by t square plus 1. Right. So now what can we do here? We are having t here and other side x here. So how can we do an integrate here? So just give it a try and try to integrate this step. So this is the simplified version. Give it a try because this integration and all you are familiar with that. So whenever we are having two variables, what is the thing we have to do? We have to bring one variable one side of the equation and the other variable other side of the equation. So let's simplify it. So dt by dx can be, so here we can take LCM, that is t square a square plus t square, right? And then we can bring all these t terms to this side and x term to this side. So now it will become t square by a square plus t square dt here, which is equal to dx here. So now if you observe, we have rewritten our equation, given equation. So in terms of x and t, and further we have rewritten that in terms of x will be one side of the equation and t will be other side of the equation. So now let's do the integration. So integrating t square by a square plus t square dt will be equal to, so if we do the integration here, it is directly x plus constant c here, right? So now the integration here will be t square by a square plus t square. So we are having a formula, so using that we can do it. So the integration here will be t minus, so that means x minus, so t minus a tan inverse dy by dx, tan inverse, so it will be x plus y t by a. So the integration here will be t minus a tan inverse t by a. So other side it will be x plus c here. So here we have assumed in place of x plus y, we have assumed t. So our final solution should be in terms of x and y, not in terms of t. So let's replace the t using x and y. So in place of t, we can write x plus y. So minus a tan inverse x plus y by a is equal to x plus c. So both sides we are having x here, so it will be getting cancelled and the equation will be remaining with y minus a tan inverse x plus y by a is equal to constant c. So this will be the solution here. But the only thing, the integration and the simplification, that's the same procedure how we have done in our indefinite integrals as well as the integrals by the application of the formulas and all. But the only trick, the only thing we have to get it here to begin the question is, we have to assume x given x plus y to be a constant, that is a variable, that is it can be a t or v, it's up to you. So here how we have assumed x plus y is equal to t and then replacing accordingly and then substitutions further and simplification required. So this will be the final solution of the given differential equation here, right? So I hope you guys got an idea here. So the trick and the step to begin this question is x plus y to be assumed to be equal to t, right? So let's move on to the next question. So as this question we have seen in detail how we can solve these typical forms of equation. So let's do one more questions related to the same typical form. So here comes the next question here. Give it a try, guys. So it is also in the format of the expression. The function is in the format of ax plus by plus c. So try to identify what will be the first step here to begin the question. So identify the given function which is given here and accordingly you can assume. So can anyone let me know what is the first step to begin this question? So the given differential equation is dy by dx is equal to x plus y minus 1 divided by square root of x plus y plus 1. So if anyone have started this question, you can let me know what is the first step that you have begun with. Because if our first step itself wrong, then the entire solution will be wrong. So by looking at the square root expression, you might get an idea how to begin this. So here we are having a differential equation that is, it is dy. So dy by dx which is equal to x plus y minus 1 divided by root over x plus y plus 1. So here as I have a square root expression here, in order to eliminate this square root expression, I will be assuming this x plus y plus 1 to be t square. So that if I substitute here, my square root will be eliminated and I will be getting an expression without a root. So that's why in order to eliminate the square root here, I have assumed my x plus y plus 1 is equal to t square. So this will be the starting step here. So you can just refer to it. If you haven't started it, you can just have a look here. So now as we have our first step, the next step will be differentiating this and replacing our given differential equation in terms of t and x. So we can differentiate this. So here 1 plus dy by dx and differentiation of 1 will be 0. So here it will be 2t dt by dx. So in place of dy by dx, we can substitute 2t dt by dx minus 1. Right. So let's just substitute that here. So here this is our LHS which is dy by dx here. So if we substitute that here, that means 2t dt by dx minus 1, and the other side in the denominator it is directly t, whereas in the numerator we have assumed x plus y plus 1 to be equal to t square, but here we are having minus 1. So if we have minus 2 here, if we could add minus 2, then this expression will be turning out to be x plus y minus 1. Right, so now which means we have to add this minus 2 both sides. That means here in place of along with the t square, there will be a minus 2 added, so that it will be converted into x plus y minus 1 which is equal to t square minus 2. So even in the numerator, we can replace with the t term, t variable, which is nothing but t square minus 2. So after the differentiation, after the assumption and the differentiation, the substitution will be in the form of 2t dt by dx minus 1 will be equal to t square minus 2 divided by 2. So now let's simplify this step by step. That is 2t dt by dx will be equal to t square minus 2 by t plus 1. So here we can take the LCM as t. So t square minus 2 plus t here. So now this will be 2t dt by dx will be equal to t square plus t minus 2 by t. Right. So now try and simplify this further in order to do the integration quickly. So first thing is we have to make all the t terms to one side of the equation, that is left side of the equation, and the x will be to the right side of the equation. So let me erase this. So far we have simplified until 2t dt by dx will be equal to t square plus t minus 2 divided by 2. So divided by t. So now the next step here will be, so let's see if anyone has given the answer so far. Not yet. So I hope you guys can give it a try for this for the simplification here. So what will be the further simplification here in order to do the integration? Quickly write that step and start doing the integration here, because you guys are familiar with the integration. So quickly do that. So you can do the integration part later if you want, because it's a partial fractions. We have to split it and do it. So let me rewrite the expression first. So it will be 2t square here divided by t square plus t minus 2 dt here, and dx will be to the other side. So now here it's a quadratic expression. So this can be factorized here. Then it will be turning out to be 2t square divided by t minus 1 and t plus 2 dt is equal to dx. So now it will be integrated, that is 2 times t square by t minus 1 t plus 2 dt, which is equal to integration of dx. Right. So here it is in terms of our partial fractions. So we have to split this and we have to do the partial fractions. Right. So if you do the partial fractions, you end up having the result to be, so I'm just writing the integration steps here. So here it will be 1 minus 1 plus 1 by 3 into t minus 1 minus 4 times 3 into t plus 2. So it's a lengthy process. You can try it later, give it a try it later, because we have already done questions related to these partial fractions and all. So the only thing here which is different and we have to look over this is the starting step and the simplification in order to get the integration step. So if you could get to that, so we almost solve the given differential equation, and the further will be, and the next will be only the simple integration which we have learned in our indefinite as well as definite integrals. So that we'll be just doing it here. Right. So this is our entire method of solving differential equation using the variable separable method for each. So here in this variable separable method, we have discussed all the three forms of equations here. So let's move on to the next method of solving. So the next method is method of solving homogeneous differential equations. Right, so first we have to see what will be the typical representation of a homogeneous differential equation. Right, so let's have a look over that. So a differential equation in x and y is said to be homogeneous if it can be put in the form dy by dx, which is equal to f of x comma y, g of x comma y. Right, so homogeneous differential equation is nothing but it's an equation which consists of both x and y variable, which is basically in the form of dy by dx, which is equal to f of x comma y. So it has to be, the function has to be involving both the x and y variables in the numerator as well as the denominator. So this typical equation, this typical form of equation, differential equation, is called to be homogeneous differential equation. Right. So both here f of x comma y and g of x comma y, so both here are homogeneous functions, and the condition here will be they have to be of same degree in x and y. So when we are talking about a homogeneous differential equation, so the degree of both the functions, that is f of x comma y and g of x comma y, has to be the same. Right. So now as we have seen, this typical form of differential equation is considered to be a homogeneous differential equation. So now the question is, if it's in the form of homogeneous differential equation, how will we solving the differential equation in order to get the solution of it? So if we are having a homogeneous differential equation, in order to get the solution, the only thing we have to do is we have to substitute Vx in place of y. If the differential equation is of form dy by dx, which is equal to f of x comma y by g of x comma y, then the substitution will be y equal to vx. So in some cases, we might even have differential equation of form dx by dy, which is equal to f of x comma y divided by g of x comma y. So in this typical case, the substitution will be x is equal to vy. So this variable we have to keep a look over here, so that in order to substitute the appropriate substitution. Right, so if it's dy by dx and this form, then the substitution will be y equal to vx. If it's on the form of dx by dy and all, then the substitution will be x equal to vy. So that's the only difference here. So the same thing, once we substitute here, how will we doing the further simplification? So let me erase this. So here in place of y, we have substituted vx. So now we have to differentiate this. That means dy by dx will be equal to v, and the differentiation of x will be 1 plus x into differentiation of v will be dv by dx. So in place of dy by dx, we are going to substitute v plus x into dv by dx. So this will be the further substitution after the assumption of y equal to vx. So these are our substitutions which will be replacing in the homogeneous differential equations in order to find the solution of it. Right, so the only thing we have to identify is we have to check whether the given function is, the given differential equation is homogeneous differential equation or not. And once it is done, once it is homogeneous differential equation, then we have to verify whether it is in the format of dy by dx or dx by dy, so that we can substitute the appropriate substitution. That is, if it is dy by dx, then the corresponding substitution will be y equal to vx, and after substitution y equal to vx, we can substitute, which means the entire homogeneous differential equation will be converted from y and x variables. It will be converted to vx variables, and after the complete solution, at last again we have to rewrite our v terms into y. Right, so that will be our final answer and the final solution of the given homogeneous differential equation. Right, so now we have understood the procedure of solving, the method of getting the solution of this homogeneous differential equation. So let's solve a question here. So here comes the first question. So the first thing we have to identify is whether it is a homogeneous differential equation or not. Take a look over the given differential equation. So you have to verify whether it is in the format of dy by dx is equal to f of x comma y by g of x comma y or not. So let's see. So can anyone let me know whether the given differential equation is a homogeneous differential equation or not? So come on guys, let me know. So the given function, here we have to observe it is in the format of dy by dx is equal to f of x comma y by g of x comma y, which means both the variables are involved here. This is the homogeneous differential equation. So it is in the format of dy by dx. So what will be the substitution here? So y will be substituted as vx. So let's do the differentiation here. That means dy by dx will be equal to v plus x into dv by dx, and let's just substitute the things here. So in place of dy by dx it will be substituted as v plus x dy by dx. In place of y it is substituted vx, so vx by x plus tan vx by x. So now here x will be cancelled and the equation will be v plus x dv by dx equal to v plus tan v, and both sides we are having plus v, that will also be getting cancelled and it will be remained as x into dv by dx, which is equal to tan v. So now if you observe, our equation is having two variables which is nothing but x and v, and now if you identify, it has been turned out into our variable separable method format, in which is in the format of our first equation form. Right, so now how can we rewrite this? So this will be dv by tan v, and the other side it will be 1 by x dx, in order to do the integration here. So dv by tan v is equal to dx by x. Right, so this is our simplified version after the substitution in place of y vx. Right, so let's the further step what we have to do, simple the integration on the both sides. So can you guys quickly do the integration and let me know the answer? Anyone? Quickly. So if you require more time, you can let me know in the comment section so that I'll just give you a few more minutes to work it on. So if you require more time to solve this question, please mention in the comment section. So give it a try and do the integration part and let me know. So as this is the first question, I have shown the steps how to do the substitution and simplify it further in order to get our integration steps. So and then further integration, you know how to do that. So I'm just leaving it to you. So quickly do the integration and let me know. So what's the answer here? dv by tan v equal to dx by x. So this can be written as cot v dv. So we have to just apply our formulas. So integration of cot v will be log sin v, right? And integration of 1 by x will be log x, and constant c will be there. But here we cannot leave in terms of v, right? So first let's, here we are having log. So log sin v minus log x will be equal to constant. So this can be rewritten as log sin v by x equal to c. In place of v, we can replace with, so what we have substituted, y equal to vx. So from where v will be equal to y by x. So this will be log of sin of y by x by x is equal to constant. Right, so that's how we'll be simplifying the terms here. Right. So as here we have seen the log. In order, if we want in the options, if this can be the answer. If not, we don't know what is this constant c. So there is one more way to do it. So that is, instead of taking this c, so there can be chances that you can get the options like this. If not, the one way, the another way here you can identify is, so here the every term sin v minus log x. So every term here is in log except the constant. So there may be chance that the constant can also be a log term. So that's why we can write it to be a log c. Then the entire log will be eliminated. So we end up having the solution to be sin of y by x is equal to c, which means it implies that sin of y by x will be equal to cx. So you can even have this will be in the options. So because we are not aware of the constant here, if every term is log, we can make the constant also in terms of log. If it is in the exponential, we can make even in the exponential because it's the constant. Right. So if you can find the option like this, it's fair. If not, you can find the answer like this in the options. Right. So this is how we'll be solving any homogeneous differential equation here. Okay, I have got answers from Lakshmi as well as Syam. Okay. So let's move on to the next question, guys. So here comes the next question, a bit lengthy. So have a look. Previous one is a bit easier one. So it's a somewhat a bit lengthier one. You can just have a look over and try and solve it. So by looking at the equation itself, we can say that it's obviously a homogeneous differential equation. But now that step is we have to substitute and then we have to simplify it in order to get our integration expression. And here along with the equation, differential equation, they have given a condition, that is, given y at x equal to 1 is minus 1, means 1 comma minus 1. X comma y will be equal to 1 comma minus 1. So we can use this condition, we can apply this in order to get the constant value. So let's do the substitution and do the simplification here. Let me see if anyone could able to. At least you can just give me the simplified version, because integration sometimes it takes time, so that we could actually, sometimes we need to use the formula directly. So there are questions where you have to use the partial fractions and all. So you can just let me know where you could get the integration step. That will be fine, I guess. So let's just try and simplify it. So from here directly we can identify it's a homogeneous. So let's substitute y equal to Vx, and further the substitution will be dy by dx will be equal to V plus x dv by dx. So let's substitute that. So in place of dy by dx, it will be V plus x dv by dx, which is equal to, so in place of v square y square, it will be v square x square here minus 2x. So it will be x square v here, because in place of y will be substituting vx. So minus x square, it will be as it is. And here v square x square plus 2x square v minus x square. So amongst this entire term, from the both numerator and denominator, we can take the x square common, which means v square minus 2v minus 1 in the numerator. Similarly, v square plus 2v minus 1 in the denominator. Right. So this x square will be getting cancelled, and we'll be having the term that is x dv by dx, which is equal to v square minus 2v minus 1 divided by v square plus 2v minus 1, and this v which is present in the left hand side, that can be pulled out to the right hand side. So it will be minus v. So now we can take the LCM. So v square plus 2v minus 1, and then here v square minus 2v minus 1. So it will be minus v cube minus 2v square and plus v. Then the numerator will be equal to, so let me write it here. So minus v cube here, and then minus v square, and then minus v minus 1 divided by v square plus 2v minus 1. So here in the numerator, the entire terms are having minus. So we can pull out the minus in common, and we can rewrite this to be v cube minus plus v square plus v plus 1 divided by v square plus 2v minus 1. So now we are having our differential equation in terms of, that is, x as well as v. So let me erase this part here. So now we are having the expression in terms of v and x, that is x dv by dx will be equal to minus of v cube plus v square plus v plus 1 divided by v square plus 2v minus 1. Right. So now what we can do, we can bring all the v terms to one side of the equation and x terms to the other side of the equation. So it will be v square plus 2v minus 1 here divided by this v cube plus v square plus v plus 1 can be written as, if I take v square common, then it will be here. If I take v square common, it will be 1 plus v here. Right, and then 1 plus v will be already there. So it will be v square plus 1 and v plus 1. So here the expression is v cube plus v square plus v plus 1. So let me take v square common. So here it will be v plus 1 and here plus v plus 1. That means again we can take v plus 1 common, and the other thing here which is remained is v square plus 1. So instead of writing this v cube plus v square plus v plus 1, we can rewrite that as v plus 1 into v square plus 1. That's what we have written here, into dv here, and minus I am just retaining to the other side itself, and minus 1 by x dx. So after rewriting all the v terms to the LHS of the equation and x terms to the RHS of the equation, this will be the formation here. So now we have to integrate the both sides of the equation. So this has to be integrated. So in order to integrate, here we could rewrite the numerator how we have rewritten the denominator here. So how can we rewrite the numerator in order to simplify it easily? So the numerator can be written as, it can have a terms which are related to v plus 1 and v square plus 1. So I'll write 2v v plus 1 minus v square plus 1. So here if we expand, 2v square minus v square will be v, and 2v plus will be there here, and then minus 1. Right, so that's why I have written 2v into v plus 1, so that I could get my terms which are present in the denominator, they can also be present in the numerator. Right, so here we'll be having v square plus 1 into v plus 1. So which will be equal to integration of minus 1 by x dx. So now let's separate these terms, and we can, in order to integrate. So let me erase this. So now we are having integration. So here we are having 2v v plus 1 divided by, so if we separate that, 2v v plus 1 divided by v plus 1 into v square plus 1 as one term, that is dy, minus v square plus 1 divided by v plus 1 into v square plus 1 as the other term, which is equal to minus 1 by x dx. So now if we do this, v plus 1 and v plus 1 will be getting cancelled, and if you identify, so we are having f dash x by, that is f dash v by f of v. So the differentiation for this will be log f of x, that is v square plus 1, because here we are having in the format of f dash v by f of v. So when we integrate this format, so it will be log of v square plus 1, minus here this v square plus 1 and v square plus 1 will be getting cancelled, and here it is 1 by v plus 1 will be log of v plus 1, and the other side minus 1 by x will be log x. So here each and every term is in terms of log. So if we want, we can even convert and write constant c here plus c. Right, so constant will be plus c. So now this can be written as log of 1 plus v square by 1 plus v here, and minus, sorry, this can be written here log x, which is equal to constant c. So now here this can also be added. So this can be rewritten as log of 1 plus v square into x divided by 1 plus v, which is equal to constant c. Right. So this constant c, as I mentioned in the previous question, so this constant c can also be written as log c, and here this will turn out to be log c in order to cancel the log on the both sides of the equation. Right. So now, so initially we have the expression that is log v square plus 1 minus log v plus 1, and the other side it is minus log x plus constant c. Instead of constant c directly, as every remaining terms are in terms of log, so I'll be rewriting this constant also in terms of c. So now this will become, so I can take log here common. So even I can bring this minus log x to the other side. So then it will become minus log v plus 1 plus log x equal to log c. So now this can be written as v square plus 1. These two are plus, so v square plus 1 into x divided by v plus 1. So here entire log, and the other side log c. So now from both sides log will be eliminated, and it is remained v square plus 1 into x by v plus 1 is equal to c. So now in place of v, we can replace, that is y equal to vx. So in place of v, y by x can be substituted. So let's substitute that. So y square by x square plus 1 into x divided by y by x plus 1. So now equal to 6. So now we can take the LCM and simplify it further. So let's do that. So v square, that is y square by x square plus 1 divided by v plus 1, that is y by x plus 1. Here we are having into x is equal to constant c. So now let's take the LCM. So it will become y square plus x square in the denominator x square into x here divided by y plus x here x, right? So this x and this x will be getting cancelled, and this x and this x will be getting cancelled, and we will be remaining with the term that is y square plus x square divided by y plus x is equal to constant c, right? So this will be the solution, that is the general solution. But here, so this is the general solution of the given differential equation, but here they have even some other conditions in order to find the constant value c, so that we could get the particular solution for this differential equation, right? So that is nothing but when x is equal to 1, y will be minus 1. So let's substitute x equal to 1 and y will be minus 1. So here it will be 1, here it will be 1, right? So x will be 1 and y will also be minus 1. So that will be, so c, so x square plus y square is equal to, so let's rewrite this. So y square plus x square is equal to y plus x into constant c, right? So we have to substitute x equal to 1 and y equal to minus 1. If we substitute, c will be ending up equal to 0. That means our y square plus x square by y plus x will be equal to 0, right? So it will be 0 and that will be the particular solution here, right? So here the given information is the x and y values are mentioned here so that we could get the particular solution, but this will be the general solution, right? So let's move on to the next one. So here what we have to aware of, so once we have identified the given differential equation is of the form homogeneous, the step will be substitution of y equal to vx. So that's it, and the further will be the simplification. So let's do one more question. So here what we'll do is, so we'll try and so it's a somewhat different from our regular way of solving the differential equation, that is a homogeneous. So let's have a look over the given differential equation and try and identify how can we start this question here. So let's see if anyone could answer this. So here the format is entirely different, which is mentioned here. So how can we try? So what can be the easiest way to try and solve it? So what is the another chapter which is attached for this particular question that you can identify? So here the given equation is y into dy by dx whole square plus 2x into dy by dx minus y is equal to 0. So here if you observe, this is somewhat related to a quadratic equation in terms of dy by dx. Right, so which means here we are having a quadratic equation in terms of dy by dx. Then what will be the solution of this quadratic equation? That means dy by dx will be equal to minus b. So here minus b is minus 2x plus or minus b square. So b square will be 4x square. So b square minus 4, a will be y and c will be minus y, so it will be plus y square under root by 2a, that means 2y. Right. So here we can take 2 common and that will be getting cancelled, because even in the square root expression there is 4, that will be coming outside. Then it will be minus x plus or minus root over x square plus y square divided by y. So now the differential equation dy by dx is nothing but equal to minus x plus or minus root over x square plus y square by y. So from the initial one, so here we are having a huge differential equation as in terms of a quadratic form. But we can't actually directly solve from that. But here as it's in a quadratic form, that is in terms of dy by dx, we can get the solution of it, which is nothing but dy by dx. So that's why from where we end up having the dy by dx is equal to minus x plus or minus root over x square plus y square divided by y. So now if you identify whether this given this derived differential equation, is it in the form of homogeneous equation or not. So can you guys let me know whether the derived differential equation, that is dy by dx, is in the format of our homogeneous equation or not. So have a look over that and let me know. So if it is the homogeneous, then we know how to solve that. So this is dy by dx, and in the numerator we are having both x and y variable function. Even in the denominator we are having y. So this also considered to be a homogeneous equation, and the substitution will be y equal to vx. So let's do the substitution and see. So far we are having the derived equation, that is dy by dx equal to minus x plus or minus root over x square plus y square divided by y. So let's substitute y equal to vx now. So here it will be v plus x into dy by dx, right? And here it will be, so minus x will be as it is, and then plus or minus x square will be there, and here it will be v square x square. Here it will be vx. So again we can take x common, that means here minus x plus or minus. So here if x will be coming out, it will be 1 plus v square here and vx here. So entire x term will be getting cancelled as it's common in both numerator and denominator. So now the term equation will be in the format of v plus x into dy by dx is equal to minus 1 plus or minus v square plus 1 under root by v. Right, so now it is in the format of v plus x into dy by dx, which is equal to minus 1 plus or minus 1 plus v square root over 1 plus v square by v, and we are having one more v here, so that can be subtracted here. So that will be turning out to be x into dv by dx equal to minus 1 plus or minus v square plus 1 divided by v minus v. So we can simplify this by taking LCM. So v minus 1 plus or minus v square plus 1 minus v square here. Right, so now this will be x into dv by dx is equal to plus or minus root over 1 plus v square minus 1 minus v square by v. Right, so now we have converted. So let's rewrite this in terms of all the v terms on one side of the equation, x terms other side. So now it will be v by plus or minus 1 plus v square under root, and then minus of, I can take common, 1 plus v square here, right, and the other side here dv, and the other side 1 by x dx. So integration and integration, and the last step required here is the only integration that you guys can do. So because so far it's a new typical type of question where you can see the differential equation which is given in terms of quadratic form. So in order to get the differential equation in format of homogeneous, we have applied our quadratic equation solution format in order to get the dy by dx, and we have further simplified it to get the integration format. So this will be the integration format, and further you can take the integration methods which we have learned and you can simplify it in order to get the integration. So that will be the solution in terms of v, and at the last, in place of v, we have to substitute y by x, right, because y equal to vx. So in place of v, y by v has to be substituted because the answer should be in terms of x and y, right. So that's all for today. So we have discussed our two methods of solving differential equations. One is variable separable method and the other is method of solving the homogeneous differential equations. So we have left with one more method, that is method of solving the linear equations. So that we'll try to cover in our next session of differential equations. So meanwhile, if you have any questions and any queries related to this chapter, you can let me know in the comment section. So that's all for today, guys. We'll just continue the rest in our next session of differential equations.